So now we'll move to Jay. Jay is going to talk a little bit about how the entire setup is done.
So as Arya and Klaus said, we have the setup here. So as you can see, just for simulation purposes, which you'll see on the screen, we have the canoe and we have created a simple UI that shows a few panels with the fuel meter display and the fuel indicator light. And here we have made a crude connection with the CAN to hook the Raspberry Pi onto the CAN. So to talk a bit more about the Raspberry Pi, we have used a WaveShare CAN hat to enable CAN communication on the Raspberry Pi, which does not have it by default. And it's just a plug and play device which you can just buy it online and plug it in and we're good to go. So it interfaces the SPI interface of the Raspberry Pi with the CAN interface, and yeah, you just need to connect it to the CAN. So now we're good to go, and we have enabled an SSH connection from our PC on the Raspberry Pi.
Jay, before you move in, so just to make things clear, this is your actual ECU that you're trying to hack?
Yes.
And that is the
simulation
yeah. Of,
and
can we say
cluster.
It's an ECU, a cluster?
Yeah.
The cluster.
Mm-hmm.
And this is the bad guy, the hacker ECU?
Yes.
Okay. Cool.
Yeah. So for today's demo, we've used Python to program the Raspberry Pi and to use the CAN. So we just installed the CAN utils package already available for Python. So if I just use a CAN dump on the Raspberry Pi, I can see all the messages that are available on the CAN. So as you can see on the screen, we have multiple messages coming on the CAN, and so for a person who has not developed these programs, who has not programmed the ECUs, these are just messages. And so if you see, there are two different arbitration IDs that are possible that we can see. And so from here starts the actual work, where we have to analyze these messages, see how they change. So like what you see is a complete CAN dump, so I can also filter for a particular arbitration ID so that I can only focus on that. And if you see, like based on this, we have identified that so the ID, the message with the ID 407 is some kind of an indicator, because you can see that when it crosses a particular threshold, the second byte changes. So based on this deduction, we have a program written which can override that. So if you see on the other screen, the simulator, the fuel gauge must be going down, and now I can force it to always stay up. So if you see now, I have understood that from the CAN dump, I have understood that the this message is coming pretty slow. And now I have written a program to put it onto the CAN message at a faster rate, so that it always overrides the actual ECU. So now what the messages the Raspberry Pi puts overrides the message that the actual ECU puts onto the CAN, and I can make the ECU behave, or the other ECU, that's a cluster, simulated cluster, behave exactly as I want. So as I told you, this requires an analysis of the messages on the CAN and a bit of a reverse engineering. Okay, so now when we run the script, the Raspberry Pi overrides the actual ECU, and so it creates it sends out fake status of the fuel status onto the cluster, and the driver can not know that he's running out of fuel. So this is just one instance where we have simulated. So, and this was just to show that the CAN bus can be easily hacked into, can be easily hooked onto, and another node can easily send messages. So it's all about identifying what each CAN message does, each CAN signal does, and duplicating the same with our interceptor ECU.